Hello and welcome to the second day of the top lesson, electricity. Yesterday we had already learned about some basics of electricity. Today's portion will be difficult to understand unless you have understood or you have read thoroughly on the first the first class, the topics that were discussed in the first class. So today's topic is combination of resistances. How many ways are there to connect resistances? So we have two ways of connecting, or two methods connecting resistances. The first one is resistances in series. So let's discuss briefly about the series connection. So here is the diagram, which is on the right side of the screen. So resistances when connected in series, the current I flows into all the same current I flows into the into all the resistances or the resistors. And always remember, for series connection, the potential difference for each of the resistors will be different. So how many resistors do you have? So depending on the number of resistors you have, each resistor will have a different potential difference. But the current I will always remain the same for all the resistances. So that's the diagram. So resistances are said to be in series if same current flows through them. So that's the first point. Then the second point if one of the resistance is removed in the connection, the current will stop flowing across the terminal, and all the other resistors also will stop working. So just imagine, looking at the diagram, if one of these resistors R1, R2, R3, R4 is damaged or it fails to function, the current which is coming from the battery, it will stop there. So in other words, the complete cycle of the flow of the current will be disturbed, or in other words, it will not flow anymore because the circuit is incomplete. So if one resistance is removed from connection, no current will flow through the circuit. That's the point. Then the third point, the potential difference is different for different resistances. I have already discussed this. So let's proceed. Disadvantage. So one of the disadvantage that we have with a series connection is that if one of the resistor or the resistance fail, the remaining resistors also will stop functioning or will stop working. Then the second disadvantage we have is the total resistance increase with increasing number of components. So if the number of resistors increases, since they're connected in series, the equivalent or the resultant resistance will automatically increase with the number of the increase in the resistors. So we'll show this with the derivation as well. So next up we have an example of resistors connected in series. This is the fairy light. We all know fairy light. So fairy lights are connected in series. If one of the bulbs stops functioning, the remaining bulbs will stop functioning as well. So that's series connection, and a best example of series connection. Now resistances in parallel. This is the second method or the second way of connecting resistors. Diagram is on the right side of the screen. So R1, R2, R3. These are three resistors connected in parallel. This is the general or normal connection diagram of parallel connections or parallel combination. Now, if you look at the diagram, you can see that the current I, which is coming from the battery, now at a point it gets distributed into I1, I2, I3. So for each of the resistors, R1, R2, R3, the current gets distributed. Then it comes out again and then goes into the negative terminal. So the current I is distributed into I1, I2, and I3. The first point. The resistances are said to be in parallel if the same potential difference has been applied across them. So our household domestic wiring system, if you look at them, we maintain only one single potential difference for all the connections that we have at our home. So now at the point where the current gets distributed and comes back, so the same potential difference, it's not shown in the diagram, but the same potential difference can be maintained across all the resistors. So that's one of the advantages that we have with the parallel combination. The current flowing through them are different, so I have explained that. The wiring done at household is in parallel. That is, tube light, fan, television, all are connected in parallel. Whatever appliances that we used are connected in parallel. That is why even if the refrigerator stops functioning or stops working, the television still functions or work, or the fan still functions. So even if one component or even if one appliance is damaged, the remaining can still function as long as current flows through them and as long as there is no problem from the mains. So that's one of the advantages we have. So talking about the advantages, when one of the components gets fused or fails, the other components are not affected. So that's the first advantage. And the second and very important advantage that we get from parallel combination is that total resistance decrease with increasing number of resistors or components. So as in series combination, the total resistance increases with the increasing number of resistors. But as for parallel combination, the total resistance decrease as we increase the number of resistors or components. So we're going to show that in the derivation and the later part. Now let's go to the derivation of resistances connected in series, or let's derive the equivalent resistance of resistances connected in series. So I'm bringing up the diagram again, but we are going to use only up to R3, only R1, R2, and R3 in the derivation. But in the diagram, I've shown you up R1, R2, R3, and R4. So let us consider three resistors R1, R2, and R3 connected in series as shown in the diagram. Let I be the current through the circuit when the potential difference is V. I'm trying to keep it short and simple. So the potential difference from the mains is V, and I is the current flowing through the circuit. So we've already discussed in series combination, the current I will remain the same through all the resistances or resistors. So as discussed, the potential difference for each of the resistors will be different. So let V1, V2, and V3 be the potential difference for R1, R2, and R3 respectively. So each of them will have separate potential difference since they're connected in series. Let RS be the resultant resistance or the equivalent resistance for the series connection or combination. Now let's apply Ohm's law for the mains. So V equal to I RS. Now we'll apply the Ohm's law again for each of the resistors separately. So for R1 it will be V1 I R1. Now the I remains the same because the same current flows through each of the resistors. Keep that in mind. So V1 equal to IR1, and for R2, V2 equal to IR2. For R3, V3 equal to IR3. But the potential difference that we have for the mains will be the sum of all the potential difference for each of the resistors. So V equal to V1 plus V2 plus V3. That's for series combination. Substituting the values, so V IRS equal to V1 equal to IR1 plus V2 equal to IR2 plus IR3. You need to look at the right side of the screen. So taking I command on the right hand side, we have IRS equal to I bracket R1 R2 plus R3. Then cancelling I and I, which are one from the left hand side and the right hand side, we have RS equal to R1 plus R2 plus R3. So this is the resultant resistance or the equivalent resistance of resistances or resistors connected in series. So let's write the conclusion. Hence, for series connections of resistances, the equivalent or resultant resistance is the sum of all the resistances connected in series. So that is the reason why the resultant resistance tends to or increases with the number of with the increase in the number of the components. So if there is another resistor R4, take an example, so the resultant resistance will be R1 plus R2 plus R3 plus R4. So that's one of the disadvantage that we have in series combination, because resistance, we will always try to avoid resistance in order for the current to flow through them smoothly. So the series combination resultant resistance. Next we have resistances connected in parallel. Let's see the diagram first. So R1, R2, R3 are connected in parallel. Let us consider three resistors R1, R2 and R3 connected in parallel as shown in the diagram. So as I've already explained earlier, the current I will be distributed or will be converted into I1, I2 and R3 for each of the for R1, R2 and R3 respectively. So let I be the current from the battery with potential difference V. Then let I1, I2 and I3 be the current for R1, R2 and R3 respectively. Let Rp be the resultant resistance or the equivalent resistance for the parallel connection. Now by Ohm's law, we have for the main, we have V equal to IRP. So the I equal to V by Rp. That's a simple mathematical step. So you just have to transfer Rp to the left hand side, which will become as a denominator. Then let's apply Ohm's law again for each of the resistor. R1 equal to V I1 R1. So I1 equal to V by R1. So similarly for R2, I2 equal to V by R2. I3 equal to V by R3. But the current which is distributed to each of the resistor I1, I2, I3 will be equal to the current that is coming from the mains. So I equal to I1 plus I2 plus I3. Look at the right side of the screen. So substituting the value, so I is equal to I by Rp, then I1 is equal to V by R1 plus I2 is equal to V by R2 plus I3 is equal to V by R3. So what can you do about this equation? you can take V common. So taking V common, V 1 by Rp equal to taking V common on the right hand side from V equal V bracket 1 by R1 plus 1 by R2 plus 1 by R3. So cancelling V, we have 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that's the resultant resistance of a parallel combination. So let's write the conclusion. Hence, for parallel connection of resistances, the reciprocal of resultant resistance is equal to the sum of the reciprocal of all the resistances connected in parallel. So the last equation that we have, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3, that needs to be converted into a statement. So the reciprocal of the resultant resistance is equal to the reciprocal sum of the reciprocal of all the resistances connected in parallel. So that's the derivation, and this is the reason why when resistors are connected in parallel, the resultant resistance decrease with the increase in the number of the resistors. So those are the two derivations that we have. So terms and facts to learn: loss of combination of resistances, series and parallel. Then that is followed by two questions. Why is series arrangement of components not used for domestic circuits? Explain. Why are copper and aluminum wires usually used for transmission of electricity? Explain. So those are the two questions, plus loss of combination of resistances, which I expect that each and every one of you will learn. And at the same time, the topics or the points that are discussed, I want you to learn them by heart, and at the same time practice the derivation and learn them. So that is for today, and if possible, you subscribe the channel, and so that you get notification whenever the videos are uploaded. Thank you.